All right, my secondary math 2 class, we are going to be talking about trigonometric functions, okay? So we are now getting into trigonometry, okay? So last time we talked about Pythagorean Theorem with our triangles. Well, today we're going to talk about some functions that allow us to not only find missing sides of triangles, but missing angles, okay? So first thing we want to do is we want to review on numbers 1 and 2 our Pythagorean Theorem. Okay, so our directions are telling us to find the missing side. So whenever it tells you to find a missing side of right triangles, you know you're going to have to use Pythagorean Theorem. So let's go ahead and remind ourselves down here, what is the Pythagorean Theorem? Okay, Pythagorean Theorem states that a squared plus b squared equals c squared. Okay? And if you remember from last time, we need to identify which sides are A, B, and C. Okay, so remember that C, so let's look at number 1. C is always our side that's across from our right angle. That's called our hypotenuse. So number 1, our C is X. Okay, well the two sides that make up the right angle, they're just legs. They can be A or B. So I'm going to go ahead and label root 37A and 15B. And don't be too scared about this root 37. It actually turns out pretty nice, and I'll show you in a second. Okay, but now that we've identified A, B, and C, we can go ahead and solve for our missing side by plugging it into our Pythagorean Theorem. Okay, so A squared, so we have root 37 squared, plus B squared, 15 squared, equals C, X squared. Okay, so this is what's really nice about this root 37 squared. Since the opposite of square is square root, and these guys are opposites of each other, they can't exist together. Okay, so they basically cancel each other out. And all that's left is what's inside. So we get 37 plus, what is 15 squared? I'm putting that in my calculator right now. 15 squared, or 15 times 15, is 225. And equals x squared on that side. Okay, well, x is already by itself almost on this side, so all we got to do is add these two together. Okay, so we get, what is 37 plus 225? We get 262 equals x squared. Okay, now our very last step to get x by itself, the opposite of square is square root it. Okay, so we're going to see if the square root of 262 comes out to be a nice pretty number. Okay, so in our calculator we can do second, then find our square root sign right there, 262, and that gives us an ugly long decimal, so we're just going to keep it as the root 262. And that is our answer. Okay, so let's do that again for number 2. So let's identify A, B, and C. Okay, so C is always across from my right angle. 16 is C. I'm going to do 13 is A, and X is B. Okay, so now we can fill it into our Pythagorean Theorem. A squared plus B squared equals C squared. My A is 13. 13 squared plus B squared equals C squared. Okay, now I can start simplifying. Okay, 13 squared, we can find what is 13 squared, or 13 times 13. We get 169. X squared, we can't simplify because we don't know what x is. And then 16 squared is 256. Okay, so now we need to go ahead and solve for x. Okay, so looking at this side of my equal sign, do I need to get rid of the positive 169 or the x squared first? I need to get rid of this positive 169, and how do I do that is I subtract 169 from both sides. So I get x squared is equal to 256 minus 169 is 87. Okay, my last steps, opposite of square is square root. So we get x is all by itself. And let's see if there is a square root of 87. Second, square root 87. Big ugly decimal, so we're just going to keep it as root 87. And there we go. Okay, so that was just a quick reminder on Pythagorean Theorem. A squared plus b squared equals c squared. Okay, well now we are going to be talking about trigonometric ratios. Okay, and here are the notes that I want us to write on our paper. So on the side of our paper over here, I want us to write S, oh, that was very shaky. S is equal to O over H. C is equal to A over H. And T is equal to O over A. Okay, you might have heard these sayings, so, ka, toa. Okay, so we have three trigonometric functions in trigonometry, or at least three that we're going to be learning this year. Okay, we have sine, cosine, and tangent. Okay, so I'm going to write that down. Sine, cosine, and tangent. Okay, it's going to ask you to find the sine, cosine, and tangent of triangles. And you're going to have to do that by identifying the opposite, the hypotenuse, the adjacent side, the hypotenuse, and the opposite side and the adjacent. Okay, so let's look at number 3. And actually, instead of cosine, I'm going to change this to sine. Not to be confused with sin. It is pronounced sine. Okay, so it's asking us now to find the sine of x. Okay, first thing we want to do is find x. Find angle x. Okay, so angle x is right there. Okay, so now that we've found angle x, we now need to identify the opposite side, the adjacent side, and the hypotenuse. Okay, well, the hypotenuse is easy. Remember, the hypotenuse is always right across from our right angle. So we know that 25 is our hypotenuse. Okay, well, the opposite angle, if we were to run straight across from this angle to the side, we'd get 7. So this is our opposite side. Okay, the adjacent side is the side that's right making up that angle. Okay, see how it's almost connected to that angle, or it is connected to that angle? So that means that 24 is our adjacent side. Okay, well, now that we know all of our sides of this triangle based on our angle x that it tells us, okay, and if we want the sine, which two sides are we looking at? So, okay, we know sine, so we're looking at opposite over hypotenuse. Okay, so how we write that is we write our opposite side, which is 7, over our hypotenuse, which is 25. And that is it. Opposite over hypotenuse. Okay, well, let's try that again. So now it wants us to find cosine of z. Okay, first thing, find z. Okay, z is that angle right down there. Okay, now we need to identify opposite, adjacent, and hypotenuse sides. Okay, well, we always know that our hypotenuse is across from our right angle, so we know that 37 is our hypotenuse. Okay, so that means that our opposite, if we were to run directly to the opposite side, we'd get 12 as our opposite. And that means that 35 is our adjacent. Okay, well, now it wants cosine. Okay, so if we need cosine, think ca, adjacent over hypotenuse. Well, what is my adjacent over hypotenuse? I'm going to write 35, because that's my adjacent side, over 37, my hypotenuse. And that is our answer. Okay, so let's do number 5. So So this time it wants tangent of Z. So again, find angle Z. It's that guy right there. Okay, so now let's identify our opposite, our adjacent, and our hypotenuse. Okay, well, hypotenuse is always across from right angle. So that means 41 is my hypotenuse. Opposite is straight across. So opposite and adjacent is connected to the angle. So 40 is adjacent. Okay, well, which two sides do we need with tangent? Okay, starts with a T, so TOA. We need opposite over adjacent. Okay, so we're thinking TOA. Okay, so we need opposite, 9, over adjacent, 40. And there's our trigonometric ratio. Okay, let's do this one more time. So now it wants tangent of A. Okay, so find angle, whoops, sorry, just bumped the phone. Tangent of angle A, so find A, it's right there. Okay, now we need to label our sides. Opposite of our right angle is always our hypotenuse. Opposite of the angle it tells us is our opposite angle. And the side opposite side, not angles. And the side that is right next to our angle is our adjacent side. Okay, well now again it wants tangent, so we know we're gonna have to use TOA. Okay, TOA is opposite over adjacent. So we find our opposite, 27, over adjacent, 36. And there is our answer. Beautiful. Okay, so that is identifying the trigonometric ratio, the fraction. Whenever you hear ratio, think fraction. Okay, well now we're actually going to find the missing side of a triangle, but notice we can't use Pythagorean theorem here because we don't have two sides to use. Okay, well this is where our trigonometric ratios come in. Okay, and you will need a calculator here. Okay, so we have, first step is always to find your angle. Okay, so if this is our angle, now let's identify the two sides that it's giving us based on this angle. Okay, well this is always our hypotenuse. And this side that's right next to it is our adjacent. Okay, so we have, now we're going to write out this equation. So we have, which function are we using? Adjacent and hypotenuse. Which one do we use adjacent and hypotenuse? Cosine. Okay, so that means we have our cosine of our angle degree, 63, equals adjacent, x, over hypotenuse, h. Okay, well, we're trying to get x by itself. So, looking at this side, what is the opposite of divided by 18? How do I get rid of this divided by 18? We are going to multiply by 18. Okay, so we have to multiply to 18 to both sides. Okay, and this is where your calculator comes in. Okay, so I'm actually going to zoom out a little bit. Okay, so if we turn our calculators on, we see that we have these sine, cosine, and tangent buttons. Okay, well, it's really nice because we can do our cosine of 63. So cosine, then it gives you a little space to type in 63. Last thing we need to do to find x, times by 18. Okay, and we get a decimal, but that's okay. It wants us to round to the nearest tenth, so that's one decimal place after. So if this is 8.17, this 7 is going to turn that 1 into a 2. So our x is 8.2. And it is that easy. Okay, it's just figuring out what you need to do the opposite of to get x by itself and punching it into a calculator. Okay, so let's go ahead and zoom in for our last example. So let's find the angle that it's giving us. So we have 71. Okay, and now what sides does it give us based on 71? So this one is actually our opposite and our adjacent. Okay, so which function uses opposite and adjacent? TOA, or tangent. So we're going to have to use tangent of the angle degree, 71, equals opposite, x, over adjacent, 20. Okay, and just like our last example, we need to get x by itself. So what is the opposite of divide by 20? We are going to multiply by 20 to both sides. Okay, and multiply by 20. Okay, so now easy peasy, just to get x, we just type this whole side into the calculator. Okay, so I'll zoom out a little bit to show you. Okay, so now you want to find tangent on your calculator. That's right here. So tangent 71, close parentheses, and we're multiplying it by 20. Equals, rounded to the nearest tenth, that means this spot right here. So the 8 behind it turns that 0 into a 1. So x equals 58.1. And there we go. Find the angle that it gives you. Identify the two sides based on that angle, and that'll tell you which function to use. Okay, those are your notes for today. There's an assignment that goes with it.